Hi, hello, this is El Profelo, and in today's video, we're going to be talking about plotting polar points. We're going to be talking about equations. We're not going to be doing equations for lines. We will be doing some equations for circles in polar and in Cartesian form. We'll be talking about converting polar and Cartesian coordinates, as well as finding the distance between 2 points. Okay, so let's work through what we have here. And it says, hey, plot these points A, 135 degrees, and B, negative 6.530 degrees. So in order to plot the points, I'm being told information about my angle and how far away from the pole I am. Okay, so if this is the pole or this is my origin, I'm going to go around from standard position 135 degrees. So I'm going to go out to 135 degrees, and then all right, if I look at this circle right over here represents being 1 unit away, and the circle over here represents being 2 units away. So here I would be 3 units away, 4 units away, 5 units away, 6 units away, 7 units away at 135 degrees. That would be point A. Okay. For point B, we have this negative 6.5 to take into account. Okay. So we could think of with point B, its complement, and the complement to point B would be 6.530 degrees. Okay. So if I looked at the complement to B with the positive, I would say go out to 30 degrees and then go out 1, 2, 3, 4, 5, 6. So then here would be the complement to B. Okay. But I'm not wanting the complement, I'm wanting B. Well, how does this work? Well, let's turn this just a little bit and let's think about this as a number line, right? Let's think about this as a number line where I'm going right out towards B in that direction. Well, what would it be if I went in the exact opposite direction? Right? Well, that would set me over there where B is, right? And literally, you can think about it just as a number line. If this is positive 6.5, back here is negative 6.5. So let's go ahead and rotate this back so we can see the information. And there we have point B, and we have its complement B prime. Okay. If I want to plot a circle, right, and I'm going to have a diameter of 4 and a center of 2, 0. All right, well, if this is rectangular coordinates, right, unless I'm told otherwise, notice down here I have the degree symbol, so this would imply polar coordinates. So here I have a center for this circle at the point 2, 0. So there is the point 2, 0, and it has a diameter of 4. So that means I'm going to go out to 4 and over to 0, which means I'm going to have this circle, right? I'm going to have this circle right over here that is tangent at this origin and has a center at 2, 0. Right? There I've plotted the circle. Now, what would be the equations for the circle? Well, in rectangular form, the equation, remember, x minus h squared plus y minus k squared is equal to r squared. And if that's the case, then I would have, right, x minus 2 squared plus y squared is equal to the radius squared. Because if the diameter is 4, the radius is 2. Okay, what about the polar equation? Well, the polar equation would be r equals 4 cosine of theta. Oh, sorry, got my full forehead in there. R equals 4 cosine of theta. How do we get that? Okay, well, if I have x minus 2 squared plus y squared is equal to 4, right? Because once again, 2 squared is 4. Okay, so if that's what I have, let's go ahead and multiply this out. That's x squared minus 4x plus 4 plus y squared equals 4. Okay, rearranging this, I have x squared plus y squared is equal to 4x. Making my substitutions, right? X squared plus y squared we know is r squared, right? X is r cosine of theta, and y is r sine of theta, right? These are substitutions for us. So we're going to replace x squared plus y squared with r squared, and we're going to replace x with r cosine of theta, right? That's the work that we're going to set up. R is not 0, so we can divide by r, and that's going to give us r equals 4 cosine of theta, right? And that is because we're setting up in r not being 0, so we can divide by r. And so that's where that equation comes from. Okay. If we look at the next one, over here, it says plot a circle with radius 1 and the center is 270 degrees. So from this, we know that we are in polar form. So if I was going to think about this, that's going to be like saying, hey, I'm going to be going around 270 degrees and have a radius at 1. So that's going to be where the center of my circle is. So that would be like saying I have the point 0, -1. Okay. And if I'm going to draw a circle around that point with the radius of 1, it's going to be tangent at the origin, right? And I can come over here and I can say, okay, well, there's my circle, right? There's the circle. Center at 270 degrees, or at 0, 1, depending on the coordinate system you're working with, radius of 1, okay? What would be the equations for that circle? Well, x squared plus y plus 1 squared is equal to 1 would be the rectangular equation, because x minus x coordinate, y minus y coordinate, there's the x coordinate, there's the y coordinate, equals radius squared. Okay. And what would be the equation for this in polar form? The equation would be r equals -2 sine theta. How do we get that r equals -2 sine theta? Well, much like we did up here. Right? Much like we did up there, let's expand this. That's going to be x squared plus y squared plus 2y plus 1 equals 1. Manipulate x squared plus y squared equals -2y. Substitute r squared equals -2r sine theta. R is not 0, so divide r equals -2 sine theta. And that's where the equation came from. Okay. Next, let's find these Cartesian coordinates for point A and for point B. Okay, so if I'm going to find these Cartesian coordinates for point A and point B, I need to remember that I can set this up using r cosine of theta, r sine of theta, right? That these Cartesian coordinates are going to be given by those. Okay, well, what do we know about point A? 135 degrees. What's the cosine? What's the sine? What do we know about point B? 30 degrees. What's the cosine? What's the sine? Well, if I work with my knowledge of the unit circle, point A would have to be 7 root 2 over 2 negative and 7 root 2 over 2 positive, because of the cosine and the sine of 135 degrees. And point B must be equal to -13 root 3 over 4 and -13 over 4, right? Both negative because we know we're in that third quadrant, right? But really and truly, where did these numbers come from? Where did these numbers come from? Well, recall that if -6.5 is the same as -13 over 2. Right? And then we just have to say, well, what's the cosine of 30 degrees? Well, that's root 3 over 2. Well, root 3 over 2 times -13 over 2. And what's the sine of 30 degrees? Well, that's 1/2. -13 over 2 times 1/2. Okay. Now, of course, we could do this just using the calculator. And if you did this just using the calculator, you would get -4.9, 4.9, and you would get negative 5.6, comma, negative 3.3, right? That if we evaluated these, this would be negative 3.25, obviously have some rounding there, okay? And then finally, what about the A to B? What if I wanted to find, right? What if I wanted to find, right, that distance from A to B, okay? Well, how do I find that? All right, and I want that magnitude. Well, to find that magnitude, I need to find the component form, once again, sorry for the forehead, of x2 minus x1, y2 minus y1, right? Well, that component form using, right, this minus this, this minus this, what we get is a negative 0.7 and a negative 8.2. Okay. So using our distance formula, which is really just the magnitude of a vector, that's going to be negative 0.7 squared plus negative 8.2 squared. Notice the use of the parentheses. Of course, I could bring my calculator on, right, and work through that. The square root, parentheses, negative 0.7 plus parentheses, negative 8.2. Whoops, that needs to be an 8. Right, and I do that, and I notice that to a single decimal place, that would be a distance of 8.2. Okay. So working with polars and their graphs and a little bit of other items. Okay, this has been Prof. Lo. As always, if you have questions, please reach out.